So, uh, over to you, Sarang. You can start and you can unmute yourself.
Hello everyone, my name is Sarang Shaikh and thank you so much Aftab for arranging this session and thank you for inviting me to do this session as a part of Microsoft program. And I just want to know one thing, do we have any time limit for the session? I was not communicated earlier for this, like is it going to be
No,
half hour or 1 hour?
it is like 1 hour as we
Okay,
communicated, but we can like go with the flow.
okay,
As
okay.
yeah,
Yeah, okay. Okay, that's good. So, hello everyone. Aftab did a basic introduction for me. So, my name is Sarang Sheikh, and I am a PhD researcher at Norwegian Department of Information Security and Communication Technology, and that's actually a Norwegian University of Science and Technology, NTNU, Norway. And I'm actually part of Mr. Pet research group, which is multidisciplinary research group on privacy and data protection. I hope you will get these slides later so you can go to this link and read more about the research group, what we are doing, and how we do it. And the major key research areas in which our research center is involved are privacy enhancing technologies, legal and regulatory frameworks, ethical consideration, user education, privacy preserving AI and ML, trustworthy AI, interdisciplinary and different application areas of artificial intelligence. So we see actually we work on both sides of artificial intelligence here at our research group. The one thing is developing and using artificial intelligence for different applications and also ensuring the ethical and privacy and data protection guidelines, because as you all know that inside Europe, the GDPR, General Data Protection regulations are quite strict. So whatever we do, that needs to be done according to those rules and regulations. So we ensure in our research group that whatever work we do with artificial intelligence, that should be under those regulations. And the today's topic, explainable AI, that is also actually one of the requirement from the GDPR when we work here for different AI based applications. Are you sharing the screen, right?
yes.
Yeah, okay. Because then I will change when we come to the coding session. Okay,
Is
so
it
talking
visible to
about,
you?
yeah, yeah. Yes, yes, it's fine. I can see them because okay, so talking about the team of our research group, so we are a diverse team of different researchers, PhD, postdocs, permanent researchers, associate, assistant professors, full professors, and the group is actually led by Professor Shule Yildirim Yilgan, and she is the head of Mr. Pet Research Group and also my PhD supervisor as well. Next, please. Saab, can you change the slide?
Is it visible? You can like
I
control it.
I still see the team slide, so okay, I can change the slide. Yeah, okay, that's fine. Yeah. Moving on next, for the application areas. So we mainly work in many application areas: smart infrastructures, law enforcement, healthcare, education, energy, and law enforcement is the area in which my PhD is going on at the research group. So I basically work with border control technologies and their acceptance, which could lead to the development and more advancements in the technology at different airports of multiple European countries. Okay, so we will start with the actual topic. This was a very short intro about myself and my research group. So you can read more about the research group at the link which was given in the second slide. starting with the actual topic, which is actually related to what is explainable AI. So, before going into that, as I previously mentioned, that in our research group, we mainly work with development of AI applications, and that development and that research should be under the regulations of GDPR, General Data Protection Regulations, which is implemented throughout in the Europe. So one of the key component or key part of the GDPR is that uh, all kind of decision making systems, decision making models, or AI based model that we develop or that are being developed, users should be aware about that decision making. So if you develop any kind of artificial intelligence model, either it is a classification model or either the machine learning model, either it is natural language processing based model, whatever you develop, and for the users, for those who develop these kind of models, either it is for doctors or you develop for engineers or you develop for teachers based on different use cases, those users should completely understand if some decision making is being done by that AI system or AI model. Those users should be able to understand why this model is giving the decision like this. So the explainability of the decision, or why the decision which is done by any machine or AI based model, this should be explainable and the user can understand in a non technical language that why this decision is like this. So this is what explainable AI target. And also this is one of the core component of GDPR, that users who use AI based systems, they should be able to understand how these things are working. Tab, I think you have turned off participant navigation, so I cannot change the slide now. Yeah. So, starting with how far we have reached now to explainable AI, if we think the whole journey of the artificial intelligence starting from the very basic, so we can divide them into three broad categories, which we call them three waves of artificial intelligence. So, the first one is symbolic AI, which was very initial and pioneer, or the building blocks of what AI we see now these days. So talking about symbolic AI, which was actually the logical and rule-based approach in AI, we can, in simple language, we can say the if-else kind of decision making, that you define some set of 10, 15, 20, 30 rules, and you allow the machine to make some decision making based on those if else rules. That was the very basic concept of artificial intelligence, which was called as symbolic AI. And then the paradigm shift to statistical AI, which we see these days. So starting from very basic machine learning algorithm, let's say support vector machine, naive bayes, KNN. So starting from those very basic machine learning algorithms to the advancement so far. So we have machine learning, then those were advanced with the introduction of neural networks. Then we had deep learning, and inside deep learning we had CNN, RNN, different kind of complex deep learning models. Then it was more advanced with transformer based architecture these days, and now we have graph based models, or knowledge based systems, which are quite hot and active these days. So all of these kind of advancement that we see so far is actually covered under the umbrella term of this statistical AI, where what you do, we train different kind of machine learning model, AI model, deep learning based model, whatever you do, we train them on some sort of data, and then we leave up to the model to make the decision. So how this is different from the symbolic AI, there we have different 10, 15, 20 rules. Beyond that, that system cannot work. But with the statistical AI model, so talking about machine learning, deep learning, they can work, they can inference from the data. So the rules they developed by performing some training on the data we give to these models, they inference. And even for those kind of rules which were not part of the data, they inference and they predict once that kind of situation or input is given to the AI model or machine learning model. So the advancement we see so far are actually come under the overall umbrella term of statistical AI. And then recently, since 4 5 years, we have started with this new term which is called explainable AI, which is actually these AI models should not only be able to make decision making or to predict anything or to give any decision making, but also these AI models should be able to perform explanations on those models which is being developed. So how this decision making is like this. So we can take an example. Let's say we have created a predictive machine learning model which could predict that either a student will fail or pass based on different input. Let's say marks in each subject, its previous academic history, its age, its daily its time, its duration of studies on daily basis. Let's say how much hours he or she study. So based on these different input parameters, let's say we have created a machine learning model which could predict either the student will fail or pass. So now, when talking about a statistical AI, this will be very simple. Okay, this will predict. Okay, this, if you give it an input, it will say, okay, the student is most likely to be fail or pass. But what happens? This decision making is of no use if we want to improve this decision making. If we just rely on pass or fail, we will not be able to improve the machine learning model to see that is the prediction is correct or wrong. And the next thing is, for the student for which you made the prediction, you don't know how this pass or fail is predicted. So you don't know the reasons, you don't know the outcomes, you don't know the basis on which the decision is actually predicted. So then you cannot improve those things for that student. Let's say the student was good in his studies, marks were good, only one parameter was very bad. That's why the model said that the student is most likely to fail. So we cannot identify that parameter in the statistical AI approach, but when it comes to explainable AI approach, we can identify these kind of things, and then we can do necessary things for the student and for improving the machine learning model as well. Then the next discussions are thing here which comes up, that why explainable AI now? Why not 10 years ago? Why not 15 years ago? Or why not 20 years ago? So the main reason is because these models are constructed to be run on good infrastructure or on good hardware. So this is the age where we have GPUs available, so we can run many complex models, either either statistical AI models or explainable AI models. Then we have a lot of data availability. The data now which is available today was not in the shape of what not available in much massive amount 5 years ago or 10 years ago or 15 years ago. The third thing is cloud infrastructure, where you have parallel processing. You can combine multiple systems to run them on big data platform, such that the processing and decision making could be very fast. You can get the decision very quickly. And the fourth thing is, which is new algorithms. 10 years ago, it was only, let's say, neural networks. We were only relying on, let's say, basic feed forward neural networks. So when it comes to processing different types of data, processing text data or processing image data with simple neural network was not much efficient. But now we have CNN, RNN, we have BERT, we have transformers, we have knowledge based graphs, we have many things in the algorithm side as well. So if we combine all these things, so you have very strong and very good algorithms these days to solve different kind of problems. You have very good infrastructure in terms of hardware. You have massive amount of data available to solve any kind of use case. And the fourth thing is, you have good on chip GPUs available which could process these massive data. So this is the reason why this explainable AI is going on hype and increasing, or is more active these days as compared to 5 years ago or 10 years ago. So this is all about the three waves of AI. So we are now in the age and the era of explanations. So the models should not only be decision making, but they should be explaining what they are doing from the machines. So talking about the formal definitions of explainable AI. So it is an AI systems which explain the decision making of any kind of model. and it ensures that the models we develop are transparent, trustworthy, responsible, and ethical. And all of these four building blocks come again under the code book of GDPR that we follow, and that is also followed all around the world as well. That the models, they should not be biased. From the bias, what I mean that there was one example in history which actually created the basis of bias in creating AI system, that they're in America and USA. Because usually we see, if we comes to the face recognition systems, so the faces of male people are more accurately identified as compared to female data, female faces. The reason is because the machine learning model or the data sets available so far contains more number of male faces as compared to female faces. And so this happened in USA, that there was a machine which was actually developed on detecting the skin color and can give the soap on the hand. So what you do, if you keep the hand in below that machine, it will recognize your skin color and the hand, and then it will drop the soap on your hand. So what happened when a white skin people put the hand, the machine started to give soap. But when there was a black person whose hand was quite black, when he or she put the hand, the machine was not able to give the soap, because that machine was not able to recognize that this is the hand of a person and I should drop some soap on it. So that was the primary thing from which this bias and transparency in AI models and machine learning models started. And that happened actually why? Because that soap machine, which which was using that AI decision model, was actually trained on that kind of data where it had very low or limited samples of black people hand and more hands of white people. So that's why it was the model was not able to distinguish at that time. So this was the one case which actually generated the questions of transparency in AI models, that these should be transparent. And Pap, can you go back? Or yeah, sorry. Okay. So, and that should be trustworthy. It means we should trust their predictions. So this is where the explainable AI also played a role, that uh, you should trust. Okay, if we take the same example for the student, the AI model predicted that the student is most likely to fail. So we should be able to trust that decision, because these days we know AI is being involved, machine learning, deep learning, they are being involved in every industry, starting from healthcare, education, construction, defense. And there are many areas which are quite sensitive, where the error chance is even point, like you cannot even have the error rate of 0.000 something. The prediction or the decision from AI model should be very, very, very accurate in order to avoid any disaster, or in order to avoid any mishap if we rely on AI for some decision making. So these AI models should be trustworthy. We should be able to trust their decisions, what we get from them. And then responsible and ethical, that's the other side, that while making the decision, if there are some input data which could lead to the misclassification or wrong decision, so the developed model should be able to understand that this is not going in right direction based on previous predictions, and this should be something else. So generally, when we talk about the models which were the part of statistical AI, we call them AI models, and they were generally, before introducing the explainable AI, they were mainly categorized as black box models. So before explainable AI, we were not aware of the thing that if we have some training data, as you can see in the figure, which is used by some model to learn the rules from the data, such that it can make some predictions based on what we give them as a new data as an input. So that new data is processed and we get some decision based on what the model has learned from the training data. And this in between box where you have some machine learning or AI model, it is actually called a black box model because we don't know how it learned, what it learned from the data, how it has decided that this should be the outcome, and we get some prediction. So generally we term them as the black box models before explainable AI was not introduced. Next, please. So the discussion going on in the same direction here as well, that conventional black box AI models, they do not provide any rational, any reasoning, any kind of support, any kind of evidence behind what they predict. So if we talk about the three waves which I explained. So if we develop any AI system without machine learning, so it is kind of a symbolic AI. So if else instructions are there which are given by some programmers, so they provide some specific instructions to the machine such that some decisions could be made. The second thing with machine learning, which is actually statistical AI, which we discussed previously as well, that we feed some data to train the models, and then these machine learning without explainability models, so the consequence which we get if we do not take into account the explainable AI, we get unhappy and confused data scientists. We cannot justify why the response is like this. So we can if we ask from the AI model, okay, why did you predict the student is fail, and it will say, okay, I don't know, I just give that according to me what I learned from the data, what I learned from the patterns, the new student which you are asking about, it should fail. So the AI will just give that, okay, it should be failed and my hands are up now. Now it's up to you what you want to do. It's your wish. This is the only decision from my side and I cannot do nothing else. And then we are blocked here. That either we should trust this decision, pass or fail, or not. We should trust or we should not trust. So this happens when it was before explainable AI, but now after introduction or after introducing the explainable AI, now we have different kind of a strategy that we will see in the next slide. So if we talk about the basic difference in explainable AI and artificial intelligence, so if we talk about black box AI, which is this first figure, so we have some data, we have any black box AI model. So it can be machine learning based model, classification, clustering, any recommendation system. Recommendation systems are another very good example for understanding the role of explainable AI. Let's say all of us, we use Netflix, we use Amazon. So if you go to the Amazon or Netflix, they recommend you some movies based on your previous history of watching. Or if you go to Amazon, they recommend certain kind of books based on your search history or based on your choice or something. So if we use only simple recommendation system with this black box thing, we cannot understand why why the next time when I log into the Netflix or Amazon and I get some recommendations, so we don't know why these recommendations are coming like this. We can ask the AI model, okay, why did you do that? Why not you recommended this movie? Why you I last time I purchased this kind of book, but why not this the book you recommended now it's completely different from the previous book. So why you did not recommend this one and you recommended this book, let's say, or this product or this movie? Okay, so this happens when we talk about the traditional artificial intelligence, which is in this statistical AI. And then once we shift to this new era, we have when where we have the explainable AI. So what we have a data, and now despite of having black box AI model, we have now explainable AI model from which we get the decision and we also get the explanations as well. Okay, here I suggested or I recommended this kind of movie to you. This is the explanation. Okay, you searched. So what could be explanations? Okay, the AI model can tell us, okay, in the last 7 days, you searched three movies similar to this movie. In the last 7 days, you watched two movies which were similar to this movies. In the last 1 month, you searched for this movie three times. That's why I thought this should be recommended to you this time for watching. So these kind of explanations we can get from the explainable AI model along with the decision. And then we can give feedback to this XAI model as well. Okay, what you recommended is good, but let's change my preferences. And now the preferences are these, and now give me some recommendation based on these new preferences. So now here we have clear and transparent prediction. Now I know why Netflix recommended these three movies to me, or Amazon recommended these to, or now why this model has predicted fail for this student or for me. So we know why this decision, why not this decision, so why fail, why not pass. We know what will happen. So now we understand that this is the decision, and this is the rational or basis or evidences behind this decision which are making this AI model to perform this kind of decision. So now here we know the explanations of the decision, we know the decision. If we think that the explanations are good, the decision are good, we trust the AI model. So the AI model now become trustworthy. It is explainable, it becomes trustworthy, we can trust the decision now. The next thing, if it gives the explanation and it gives the wrong decision and the explanation for the wrong decision, we can give feedback to the AI model. Okay, let's change the data now. We have previously we used this kind of data. Now if we want to improve these decision makings and these things, now let's give the new data to the AI model such that this wrong predictions, wrong decisions should be improved, and we can get more fine tuned, more correct, more understandable AI model. Yeah. Next, please. Okay. We already discussed one need of explainable AI, which was due to which was actually based on why XAI now actually. So why we are doing it now, not 10 years ago or 15 years ago. So that was the need of its introduction, that why it is introduced now, not before. So that we already learned. We have now good hardwares, we have new algorithms, we have infrastructures, we have what was the fourth thing? We have massive data. So that's the reason that XAI is increasing these days. The next thing is that we discussed with different examples. So this is actually replicating same kind of discussions which we did in the previous slide, that why I'm getting this kind of decision and how can I get a better decision, which I also explained in the previous slide, that we get some decisions along with some explanation, and now we can improve and enhance this decision making process in any kind of AI model. So we have black box AI model which gives some poor decision to us, and then we are confused why we are getting this decision and how we can improve this decision. So some examples or some users which are not, so let's say if that machine learning model is deployed for some business, let's say it's a business ABC and they are working on giving loans to the customers, and we fed some input features, input parameters of a specific customer to this black box AI model, and we want to see that if this customer will return its loan to us on time or not. And the black box AI said it will, the customer will make the fraud and it will not return you on time the money which you give to the customer. So now the business owner can ask you, okay, if you are a data scientist, if I am a machine learning engineer and I design this solution for this business, so the business owner can ask me, can I trust our AI decisions? Can I trust that if the AI model is saying that this customer will be fraud or this customer will not be fraud? Can I trust this decision? If I say yes, that would not be sufficient or enough as a machine learning engineer who developed the model. Why? Because I cannot give the explanation. Okay, you see, these are the rationals, or these are the explanations that suggest that this decision is correct. So the business owner can ask, can I trust our AI decisions? The customer suppose the customer support can also ask, okay, how we resolve this kind of complaint. As a data scientist, we can, if there are no explanations, as a machine learning engineer myself, I can also be, uh, if I'm a machine learning engineer, so I should be also able to uh, trust my model. So I there's the question mark coming in my head as well. Okay, is this the best model which I could develop, or there are any improvements needed? So this XAI is actually helps you to understand the explanations for the decisions so that you can improve all these decision making. Aftab, I see one question in the chat. So should we take the questions now, or we take the questions at the end?
Uh, you can take it.
Okay. So, okay, it is, if black box gives poor decision, then why would we use it? See, if it is giving poor decisions and we are deploying or we are creating or building these AI models, and we know from some accuracy or from some precision or from some recall that the decision is not good, the model is not good, now we need to enhance it. It is not all about using it. If it is a poor, that we should not use it. It is like, you completely avoid that. Okay, let's not go towards the artificial intelligence and we will do the things manually like they have been so far. But the thing is that we want to automate the things, we want to include the role of AI. So if the decisions are poor, we have the role that using different techniques and using different new things, we should be able to enhance their decision making such that they could be more improved. That is the reason that we ask here, how can I get a better decision? So through XAI, we learn that what things are making this model poor. So let's work on, is it the data? Is it the model? Is this processing? So what's going wrong? And so that we can improve the model and we can get some better decisions on it. Okay, we have how data science relate to AI. Okay. Generally speaking, we can say it's actually the differentiation of different naming convention and different roles. When we talk about general AI, it's a field which we study for making any kind of intelligent systems. We can say AI based systems, intelligent systems. And when it comes to data scientists, they are actually the developers, the users who work in the field of AI. So it really depends that what kind of work you do. If you purely work with all kind of data, from data gathering and requirement gathering to the end of developing any AI or machine learning based model, you can be classified as a data scientist. If you work any specific a part of this whole full machine learning cycle, that's the other story. So you can be as a part of at different stages in that machine learning full pipeline. So whatever work you do, that decide your thing, or that decide your title. So data scientist, machine learning engineer, data engineer, cloud engineer. Okay, so we have how does XAI work. So now in the explainable AI, we have this actually complete feedback loop, what we call. And what we do is, first we train any kind of machine learning model. You train you using Python language. Whatever you do, you have some data and you want to train any model for performing certain kind of task. Then you have training of the model, then you test the model, and then you deploy it. for performing real use cases. So here on the train and on the QA, what we usually do, it's just the training on the data, and here we test, okay, on the test data, if it is working fine. The actual role or actual performance of the AI model comes when it is deployed as a real in real time settings. So what I in the previous examples, when you deploy the model real time in an organization where you input any in real customer information to see that if the customer will return the loan on time or not. So uh, that is actually the real use case where you use AI model for performing some decision making. So you deploy them, and then you have explainable decisions. So you get the decision yes, no, 1 2 3 4 5, pass, fail, survive, not survive, any kind of decision for which is for a specific use case. Along it with you get some explanations, and then with those explanations, what you do, you perform uh, different A B test to see that how this is compared to the real use case. So you have some performance monitoring as well, and what you identified from performance monitoring and the testing and the deployment, you identify and debug what kind of problems you see in your AI model based on all these discussions. And then you again improve your AI model, you train again, you deploy, you test in the real settings, and then you monitor the performance. And fairness monitoring is also this trustworthiness, that the predictions that you get and you have the explanation, so you decide either to trust the decisions or not. So that comes under the fairness monitoring. And the performance monitoring is actually if the decisions are correct or wrong. So you debug all these things. So it is actually a continuous process, because on daily basis you will get new data, you will get new information. So this is a continuous process which is being followed when it comes to XAI. Okay, so we have two questions. Is it worth going into the data science field and software compared to job ratio in Pakistan? See, if we talk about software development, it comprises of all kind of development. So it's still up to you what you like. Talking about job ratio, if you are in IT, if you are in software development, what you do, that is accepted by the industry. If you are up to date, you use new technologies, you learn the things which are up to date with the industry and with the job announcement, job positions in the industry, then you will have many chances. So it worth it worth working in any kind of computer science field. So software development, data science, everything is fine. What is difference between model deployment and production? The deployment is actually it is still in house. You maybe sometimes you we deploy and we test it during the real settings, but the production is actually you put it into the complete real environment, which is completely unseen for the AI model, so that a very fresh and new data should come and you can see the decision making. Okay, can we have the next? And we will take few questions then later as well. Okay, so here comes the fun part, because all the things have been so far theoretical definitions and bookish based things. We learned and we understood how what XAI is, how it works, what benefit we get, and why we should use it. Now it comes the fun part, which actually, because we are the computer science uh, students, researchers, teachers, professionals, so we can have it is still, if we just talk about theoretical things, it's of no use until we see the things in working and in let's say functioning, or we see them in practical. So The increasing hype of explainable AI is due to one more thing as well, which is actually introduction of many libraries that can be used to implement different explainable AI algorithms and explainable AI techniques. So I have listed couple of libraries here which are open source available to develop explainable AI things on any kind of data. You can take tabular data like numeric data in row column. You can take image data, you can take text data. I have We have developed couple of examples for you as well to understand how xai can be beneficial to understand this black box thing. So the first very common library and most easy library to start with explainable AI is LIME, local interpretable model agnostic explanations. Then we have SHARP, testing with concept activation vector TSEF, DELX, and Interpret ML. So the most basic and easy library to start with understanding explainable AI is LIME, and this is what for this library we have prepared some of the coding examples for the participant. So you can, after the session you will have the slide, so you can go and study against each library, that how each library works with the xai thing. So talking about lime, which is a novel model agnostic local explanation technique used for interpreting black box models by learning a local model around the prediction. So what does lime do? You train a model on a certain type of data, you make some decisions with the prediction with the test data. Now you have the test data and you the predictions also. What you do, you give that data and the prediction to the lime, and lime explain you that if the decision is yes or no. So here is the explanation why it is yes or no. So this is, so it works around learning about the predictions. So the model is already there which has learned the pattern. What does lime do? It just open the that model which has learned all the patterns and evaluate that prediction on that pattern and give you some easy explanations that this is how this decision is made. So it provide a global understanding of the model, that how model is functioning with different use cases. And this technique was first proposed in the research paper which was why should I trust you, explaining the predictions of any classifier. So if you want to learn more about lime, that how mathematically it works, how lime explain the predictions, you can refer to this paper as well which is mentioned in the slide. So, starting with some examples of the lime, we will be having some basic introduction. So, in the introduction to lime notebook, we will explain, I will explain some, we have this very famous data set Titanic, the people where we will have decision making of a specific person as survived or not survived from the Titanic incident. Then we have the text data, line with text data. So we will have some reviews of positive and negative, and we train a model to identify which review is positive and which review is negatively written, and we will have some decision. And then we will see how lime explain the decision with the text data, and this discussion goes on with the image data as well and with the tabular data. So now we will have four different, to uh, I will try to explain them as brief as possible. I will not run them because the codes are already run and we have the output of each cell. But you can get these collab. You can directly download these collab file letters, and after the session, the data set used for these notebooks, I will share them with with Aftab, and the participants can get that if they are interested to work on this. So Aftab, maybe if you allow me to share my screen because I have notebooks open on my side, and then we will do the conclusion at the end. So should I share my screen now? I have the rights.
Yes, you can now.
Yeah. Let me check. Okay. Do you see the screen of code
Yes,
different? Colab
Yes,
notebooks.
it's
Okay.
visible.
Okay, so we first start with introduction to Lime, and we'll see how Lime framework is used for explaining any kind of classification model. So here we will use a very basic Titanic dataset. So because it's the collab, so we install some necessary libraries. So pandas, NumPy, Matplotlib, which is used for, and Seaborn, they are used for visualization. Scikit-learn is mainly used for implementing machine learning algorithms, and then we have Lime, which is this is the major library. So if you have all other libraries installed because you work with the AI and machine learning, so you can just use pip install Lime and it will install all the necessary dependencies of the Lime library. And then we have XGBoost as well, because we'll be mainly using in this tutorial we'll be using XGBoost classifier for performing some classification and then explaining the decision. Okay, we have some imports. So for the Lime, we do the basic import. Okay, Lime tabular, because we are working with tabular data and some other necessary things. Of course, in this tutorial, I cannot cover the whole library of Lime. I can just explain some example, but the internet is open. Lime has its own full GitHub available, where you can see all the functions and modules which are available with the library. So we have a Titanic dataset that we downloaded, and if we load it in, that's the titanic.csv, and if we load it, we have some information there in the dataset. So we have passenger ID, and either it was survived or not, so 1 or 0. So the data point with ID2, it has some name, gender, age, some ticket, how much was the fare, what cabin the passengers was sitting in at the ship, and it was survived or not. So we have, this was not survived, this was survived. So the main decision making, the classification model that we're going to develop, it will help us to predict, if we give it some features from this data, it should tell us that the passenger was survived or not survived. Here are some basic pre-processing things that we have the data. So what is the shape of the data? We have total this row and these 12 columns. What are the columns? We perform some replacement if there are some null in the data set. So we replace them with question mark. We check anything is null or not in the data set. This is the basic data science and ML things that we usually do on our daily basis. So this is not much extensive thing. And then there are some irrelevant column which cannot support or are not necessary for to be used as an input to do the prediction of survival or not survival. So we remove these columns from the data, and we have age and fare as the number, so we convert them into float. We have gender as a categorical column, it's male or female, so we also convert those, because the model cannot understand male female, but it can understand 0 or 1. We all know that machine learning model, they understand numbers, they do not understand text. For the text we need to convert them into numbers. So when you have any categorical kind of feature where you have different options for any column, you use label encoder to convert them into numbers. So now the age and gender become 0 and 1 instead of male and female. So what we do, we have some features now. We drop the survive column because this is our outcome column, output column, which will be predicted by the machine learning model. And so the features is all the columns except the column survived, and the column survived is actually our label now. So this is our input and this is our output for the machine learning model. We do some standard train test split on this by keeping 80% of data as a test and 80% as training and 20% as test. Now we create a machine learning model, a AI based decision system that is based on XGBoost classifier, and we train it on some data. So we have some X train here. So this is the training input and these are the corresponding labels. So what this model will do, it will learn the pattern that how the passengers who survived, how, what was the values of those passengers, what was the age, what was the gender, what was the other things. And we have some labels for survived and not survived. And then we learn the score of model on the test data set, and we see that we have some reasonable accuracy, we can say 77%. Although in the age of this AI, we always talk about accuracy is above 90%, 95%. But because this is a very limited data set and the model is very limited, so we just selected it as an example purpose. So you can implement any kind of machine learning model and you can see. So we have some 77%. Now let's see how XAI explain this accuracy which we have for the test set. What we do, first of all, we create a prediction function from this model predict probability. And now what we do, we create an explainer from explainable AI library, and we say, so we give the data, the features, we tell the model that it is not a regression or any kind of problem, but it is a classification problem where we have two classes, did not survive or survived. And in the training labels, this you can take the data from here and the features are here. So we have features already here. So we tell the features to the line, we tell the training labels, we tell what are the classes of classification, and we tell the mode. And now we define some index for which we, so this is actually index of the test data set, so for which we want to learn the explanation. And then we have this exp where we say explain instance, explain this instance which is on zero index from data. So we have all the data and we ask the explainer that if you learned or you made the decision based on, let's say, 10 features or 15 features or 20 features, but just only take 5 features, top 5 features which were important for the model, take those 5 features and explain why this prediction was like this, why this decision was like this. So when we show it in a visualized form, we see that for the survived, it predicted 1.0 and did not survive 0.0. So this is 0 level, this is 1 level, and it is highlighted as survived. So the model predicted as for this instance that the passenger was survived. Here we can see the features which were involved in performing the decision making were gender, this P class, embarked, this one, and this feature, and their value range as well. So the gender was actually less than less than equal to this, and the actual value also which was used by classifier to make the decision from all these features. And we see them also. This shows hierarchy as well of the feature, that the most important feature for the AI model or the machine learning model to make the decision was actually gender, because it comes at the top with the maximum value 0.53. The second feature is 0.23, the third feature is 0.09, 0.07, 0.06. So from this we understand that how each of the feature how much contributed while making this survive prediction and what were the values also. So we can also see them as a list in numbers. And there is another one, we can, if you try to visualize and plot it, it can also show you the, from this plot we can also see the gender feature has maximum impact while making the prediction, and rest have very less impact as compared to the gender feature from the data. And then if you want to do it for many instances to see that how different decisions are coming up, they have another function which is called submodular pick, where you pass this explainer object which we created above, and you also tell that you want explanation, let's say, for 5 examples from the data set. And when you show it in notebook form, it show you different instances. So for this instance, did not survive was 0.97 and survive was 0.03. So the models will say that the passenger did not survive because maximum probability is here. Here, this is for survived. Here this is did not 0.60, but the major portion is toward did not survive. And because it's a binary classification, so this did not survive has higher probability. We will see the outcome or prediction of the classifier is did not survive, not as survive. And here we can also see that if these decisions, how which features, what values. So basically, so now if we replicate this same problem with the examples which I discussed previously for the student. So let's say inspired instead of all these features, you have, let's say, gender, age, and third feature you have, let's say, its academic history. Then you have some marks, and you have the class label as pass or fail. So if the model says pass or if the model says fail, you can see here which feature contributed most while making this decision, and what was the value and numbers of each of the feature which they take into account, which the model take into account while making the prediction. So you can explain to them, the student can get the explanation. If the AI model says I'm gonna fail, or I'm gonna pass, why it is like this. So we can tell the student that based on this information we can say that you will likely fail or you will likely pass. Or the decision makers who have to do make some decision based on these information, they can also understand that why this is yes, why this is not, why this is zero, why this is one. So this was a very first example that how you can work with lime with the tabular data. The next example we have is actually working with lime on text data. So we loaded and we created some sort of this. I will not go on explaining from the top because these are some basics NLTK in the basics of machine learning and natural language processing. What we did, we have some sort of data like this where each row contains one review, and where one, and in the label column, one represent positive and zero represent negative. So we have a data where we have some text and the corresponding label either one or zero. We do some pre-processing, we train a model, we create features from the text because the model cannot directly understand the text data. So we create TF-IDF feature, we train them, we test, we train the model, and we get some score on the test data set, 80% or 81% or something. Now, when it comes to explaining these explanations with the text data, so here we will we make some pipeline explainer, and now instead of here we had, if you remember, into this text data for the explainer, what we did, we use lime tabular explainer because the data was tabular. But now we have lime text explainer because the data is text. And we say, because the review we have in the natural language in the text form, and we say negative, the classes can be two, either negative, either positive. And what we do, okay, we define here that in the data set, take the instance with the index 45. So it is up to us how we give input to the explainer. It's just up to us which instance we want to get it explained, either one, either many. So we call it that take the instance at 45 index from the dataset, and the classes is negative or positive. And now explain this instance from the test dataset and take only 5 features while explaining the instance. So these are some probabilities for each of the word, because we know that when it comes to perform classification on text data, so words are actually treated as features. There we have columns, each feature which is being used as the input to the machine learning model. But when it comes to perform text or natural data, the words are actual features for the model to learn. So what it will do, it will first tell you that for each of the classes, how much is the model confident, for negative how much is the confidence, and for positive how much is the confident. And then from the text which is available at this index, it will also highlighted most important words which have contributed making this decision. Previously, if we talk about black box AI or a simple AI models, we cannot, we don't know, okay, the model predicted that the review is negative, but why it is negative? What are the explanation? What are the rationals? What are the things that comes that happen or that make the model to predict or to make this kind of decision either positive or negative? So now we can say, okay, we have explanation. There are some words in the text which looks negative, and these are the words which are in the text which looks negative, which make the model to predict negative, or these are the words in the text, the highlighted words in the text which look positive, and these are the reasons which made the model to perform, to make the decision as positive. So moving on ahead with the image data, because this is we have some quick examples with here. With the image data, what we are going to do, let's say we have one image which we have downloaded from this URL. It's a shark. Okay, we can see it. But now we need an image classification model which could tell us that what this image look like. We perform some transformation on this image, and then what we do for this task, let's say we are not creating any image classifier, but we are downloading a pre-trained model exception to which we will give this image. So we have a model exception, and we have created this function which could predict the class of the image which we give it. So what we do, we have this normalized image, and we have this get model predictions which is based on this exception model which is already trained on millions of images, and we give it some image and we ask it to predict what is the class of this image. So now we get, okay, the predicted class is tiger shark. Okay, we are happy that this predicted correctly. Okay, this looks like a shark, but what did it used, how it identified that this is a shark, and because we see many other things inside the image as well. So now how we can use lime with the images to understand that how model identified this is a fish, or oh, this is a shark. So now we will use Lime Image Explainer. So we have Lime Tabular Explainer, we have Lime Text Explainer, and then we have Lime Image Explainer also. So we explain and we give input. So this is the image input which we give, and this is the predict function which we have for the model. We give top 5 label, and we say that take number of samples as 1000, and we run this, and we see something like this when we plot this output from the lime. So this is not very explainable, but if we create it, so what this generate prediction sample, it has some sort of options that you can set to make the things more visible. So if you hide the background, so now this explainable AI is telling you that while the model was predicting the shark is fish, so from the whole image, the model used this area of the image to understand that how the highlighted area which is with yellow, the model used this area of the image or this feature inside the image to see that it is a shark or not. If you make the hide background false, you can see it more visibly that from the whole image this yellow highlighted area was the major part which was actually used by the model to understand that it is a shark or what kind of object. So you can do different thing, you can make show positive false and background false, and you can see some green area. So it is up to you how you want to visualize the decisions which you have. You can create some heat maps also, you can do something like this. So it is still, it depends on you that how you want to do it. So this is how you can work with the image data also. If you don't want to use this exception pre-trained model, you can train your own model. Let's say you have an image data set, let's say this faces of male and female data set. You can use that data set to train a machine learning or deep learning model and give it some input of a male or female face. And then with Lime, you can try and you can see that it will explain that what region of the face were used by the model to do the prediction that either it is a male face or it is a female face. Is it a happy emotion face or it is a sad emotion face? So this is how you can explain what is being predicted or what decision is being done by the model you create. So it can be deep learning, it can be machine learning. And just for your information, this Lime library, it works with all the common libraries of machine learning and deep learning. It is compatible with scikit-learn, it is compatible with TensorFlow, it is compatible with PyTorch, it is compatible with all the pre-trained model, these exception, zero shot learning, and transformer based models. So it is compatible. You will get all the examples over the internet. So it is compatible with all kind of libraries that are being used these days for performing machine learning and deep learning related tasks. And this is additional notebook which I also developed, so you can, the participants can go through it from later. It is also based on some tabular data, but instead of classification it is a regression based explanation. So you do not see two options here, but you see a range of because we know that regression is a prediction when you want to predict some continuous number, not any discrete number. So it will show you that the maximum is this, minimum is this, and you lie here. That's why this prediction is like this. So it is based on the regression. So you can go through this notebook also later when you try to practice on this. Yeah. So I will stop my screen sharing now, and maybe Aftab, you can share again and we can go through the conclusion and we can then take the questions.
Let me share this. Sorry, I'm unable to find the PPT. You can conclude it.
Okay, so it's fine. So the conclusion is we even I think I have available, but it's fine. I can share from my side if you just give me 1 second. Okay, you see the conclusion, right? Yeah, so we explored the
Right.
fascinating world of XAI. We learned how AI is being integrated into our lives and why we need transparency and understanding in AI decision making, and why it is crucial. You can more deep dive into this topic, and you can get back to me also if you're interested to work on any use case and want to work on any research topics. We have many topics available, so all the participants, if they are interested on working on any topics, they can get back to me also. So this is my contact information, my email, my number, and my university profile, my Google Scholar profile. So yeah, thank you so much, everyone, and thank you for this invitation, and thank you for listening.
Thank you so much for such a informative session, Sarang. Uh, it was really nice. So we are going for Q&A session. If anyone have any question, you can ask. Let me allow you to unmute yourself. Yeah. Abdul Kadir, you can unmute yourself and ask the question.
अस्सलाम सरंग भाई।
वालेकुम अस्सलाम अब्दुल कदीर।
क्विकली
आपसे
क्वेश्चन
पूछना हूँ
कीजिएगा क्योंकि हमारे पास
जी
शॉर्ट
बिल्कुल।
टाइम है तो
जी
या
असल में मेरा जो है ना क्वेश्चन था इसके रिलेटेड, तो मेरे पास 2 क्वेश्चंस हैं। एक तो यहाँ चैट बॉक्स में एक लिख दिया है क्वेश्चन, और दूसरा मेरा क्वेश्चन ये है कि जो मेरे पास एक डेटा सेट है ना, ऐसे का डेटा सेट है, सही है, मैंने केगल से उठाया हुआ है। तो उसमें ये है कि मेरे पास जो उसके लेवल्स हैं ना, वो मिसाल लेट्स सपोज मैं कह लूँ कि उसमें ऐसा हो रहा है कि मुझे जो है ना 7, 8, 9, 9th और 10th क्लास के लिए मतलब कोई ऐसे का सिस्टम बनाना है, ऐसे प्रेडिक्शन सिस्टम बनाना है, सही है, किसी स्कूल को देना है वो। तो उसमें एक ये चीज़ आ रही है कि मुझे तो उसमें पहले क्या चीज़ करनी होगी, और दूसरी उसमें जो है ना लेबल्स वो वाले नहीं हैं। जिस तरह मैं कहूँ ना कि अगर हमारे पास इंग्लिश में डिफरेंट ऐसे टाइप्स होते हैं, जिस तरह हमारे पास डिस्क्रिप्टिव ऐसे होता है, नैरेटिव ऐसे होता है, और एक्सप्लेनेटरी ऐसे होता है, और बहुत सारे टाइप्स होते हैं। उसमें वो उसकी जो है ना कैटेगरीज नहीं है उस डेटा सेट में। लेकिन ये है कि भाई ये जो है ना आप उसका स्कोर मिसाल तौर ये 7वीं क्लास का जो है ना डेटा सेट है, ये 8वीं क्लास का डेटा सेट है, मतलब प्रीवियस डेटा सेट हमारे पास के हैं उसमें।
ओके, जस्ट अ सेकंड अब्दुल कदीर, हम इसको कंटिन्यू
जी
कर
जी।
सकते हैं। असल में ये है कि ये ना एक फुल डिटेल टॉपिक है और डिटेल प्रॉब्लम स्टेटमेंट है, ठीक है? तो ये पूरी सुनने के
श्योर श्योर।
से पहले और डेटा
जी जी।
देखने के बाद मैं इस पे कमेंट इतना
जी
जल्दी
जी।
नहीं कर सकता। तो हम ये कर
श्योर
सकते
श्योर।
हैं कि मैंने कॉन्टैक्ट इन्फॉर्मेशन शेयर की हुई है, तो आप उस पे मुझसे कॉन्टैक्ट करें, ईमेल या व्हाट्सएप जो भी, और हम कोई एक टाइम
श्योर
स्लॉट रख लेंगे, तो मैं आपको उस पे गाइड कर
श्योर
दूंगा,
श्योर।
कोई मसला नहीं, ठीक है? यू
थैंक
कैन
यू सो
कम
मच।
बैक टू
अगर
मी
आपके
विद
पास,
दिस इन पर्सन और हम फिर उसको डिस्कस कर लेंगे,
श्योर आपके पास लिंक्डइन है,
ठीक है?
क्योंकि मैं आपको वहाँ पर रीच कर दूँ।
जी, मैं लिंक्डइन पे हूँ,
लिंक्डइन,
यू कैन सेंड मी द मैसेज देयर।
तो यहाँ पर अगर आप उसकी लिंक शेयर कर दें तो मैं आपको रिक्वेस्ट
आई
सेंड कर
थिंक
दूँ।
यू कैन, मैं कर देता हूँ चैट में, ठीक है?
थैंक यू सो मच।
If anyone have detailed question, they can contact directly to Sarang. So अगर आपके पास कोई शॉर्ट क्वेश्चन है तो आप खुद को अनम्यूट करके पूछ सकते हैं। Anyone? I think no one have any questions. So I shared the form for e-certificates, LinkedIn Premium referral, and DataCam Premium lessons. So you have to like submit this form, and we will do a referral here for LinkedIn Premium.
Now is it also for the instruct, like for the session as well?
Sorry. Uh,
लाइक जो इंस्ट्रक्टर हैं उनको भी फिल करना है या सिर्फ पार्टिसिपेंट्स को ही फिल करना है?
सिर्फ पार्टिसिपेंट्स को, इंस्ट्रक्टर के
ओके,
लिए तो बिल्कुल होगा. Yes. So
ओके।
we have some responses here. So kindly जल्दी से आप जो है ना फॉर्म फिल कर दें तो हम रेफर कर लेते हैं यहाँ पर. Okay. I think I we can do referral. Okay. So is it visible to everyone? So we have 36, 35 names from participants. I think many of you are missing this form. Should we wait or should we do referral?
काइंडली वेट, मैं फिल कर रहा हूँ।
जल्दी से कर लें. Quickly, please. Everyone. Wow. only 5 people are remaining. Can we quickly कर लें तो हम 4 people left. तो सारंग भाई, जब तक ये लोग फिल करते हैं, एनी कमेंट्स फॉर ऑडियंस?
Uh, Comments for audience is के this is growing field, not only explainable AI, जितने भी aspects हैं AI related और technically research side पे, so things are changing, things are growing, opportunities काफ़ी ज़्यादा हैं. The only thing that is in demand is कि आपको skills होनी चाहिए. अगर आप research side पे जाना चाहते हैं, industry side पे जाना चाहते हैं, try to make yourself updated. खुद को अपडेट रखें, नई चीज़ें जो आ रही हैं उनको एक्सप्लोर करें और जितना खुद को स्किल बनाएंगे उतना आप इस फील्ड में जो है वो यू कैन गो फार. तो अपॉर्चुनिटीज़ बहुत ज़्यादा हैं अगर आप खुद को उनके लिए रेडी कर लेते हैं तो. So this is the only comment and also another comment for you कि ये इस तरह के जो सेशंस मैं फॉलो करता रहता हूँ, पहले भी आप करते रहे और ये आज आपने मेरे साथ किया है तो दिस इज़ वेरी गुड. आई रियली लाइक द इनिशिएटिव और गुड लक फॉर द फ्यूचर सेशंस आपके लिए और गुड वर्क सो फार. या
Thank you
वेरी
so
नाइस.
much.
या
So I have a question. XAI is also in job market, or it is only in research?
No, it is also in job market. Like as I already told, it depends that where you are working, and because it is now being integrated here, at least inside Europe, because companies here now, what they do, any if they are using any different kind of AI decision making in their premises in their organization, so they are implementing XAI these days to understand the the AI models they previously built for just for simple yes no or performing any decision, but now they are improving them with the XAI to see how why this model is behaving like this.
Okay, great.
Yeah.
So we are here for LinkedIn Premium winners and Data Cam winner. So we will select three participants, two for LinkedIn Premium and one for Data Cam Premium license. So first will be for LinkedIn Premium. So that is Muhammad Talha Sheikh. Second LinkedIn Premium will go to, let's see, it's Pritam, and DataCamp Premium license will go to Masira Fatma. So congratulations to all three winners. Thank you so much everyone for joining this session. I hope you enjoyed this session. Uh, Thank you so much for joining. Allah Hafiz everyone. Have a good day.